Well, hello everyone, and thank you so much for tuning into this video for your homework tonight. I'm just going to go over a couple of problems, some problems that we talked about in class today, remodel those and show you how to solve those, give you the chance to do them yourself and check your work, and then follow that up by practicing on your own. The key components that we're going to talk about are adding fractions, two fractions or subtracting fractions that have different denominators. So that will be the focus for today's video. So stay tuned, and here we go. First two problems that we're going to take a peek at are 1/2 plus 1/4, and then we're going to look at 2/3 plus 1/9. Now, this might be elementary in regards to going over the material, but I just want to make sure that everyone is on the same page with the vocabulary of the numerator and the denominator. The numerator being the top value and the denominator being the bottom number. Remember, a fraction refers to part of a whole, so this number here talks about a part of an entire entity or a part of an entire part of a whole. So let's look at this first problem here. We have 1/2 and then 1/4. So my first question is, how can I make these denominators right here be the same number? I have 2 and I have 4. I ask myself, could I multiply either one of these numbers to be the same as the other? Well, I know that 2 times 2 is 4. So I'm just going to write this in here in blue. I'm going to say 2 times 2 is 4. Now, I always multiply my numerator and my denominator. You might be asking why. Well, if I had a circle right here, or a pie, and originally my fraction was 1/2, and I just multiplied the denominator by 2, that would actually be a 4th. So they wouldn't be the same amount. So that's why you multiply the numerator and the denominator by the set multiplier. So now that I figured this out, I'm going to draw an arrow down because I always like to rewrite my problem. That's the proper way to do these problems here. You can do them in your mind, and that's fine, but to write down the work is a very important step in this process. So we look at this numerator, 1 times 2, and that's 2. Then 2 times 2 is 4. That 2 times 2 came from right here. Then we're going to add on 1/4. That never needs to change because now our goal is that these denominators match up, that they're the same. So I add them together, I add together the numerators, and that's 3/4. 3/4. Okay. Now press pause in the video, and I'd like for you to try the second problem on your own. My voice will stop here just for a second, and you can press play when you're ready. Okay, well the answers are in, or the answer's in, and the answer is 7/9. How I've looked at this problem is I said, okay, what times 3 will get me to 9? 3 times 3 equals 9. And I then calculated that together to find that the equivalent fraction, or the fraction that shows the same amount as 2/3, is 6/9. Because they have the same denominator, I was able to add them together for a total of 7/9. Okay, now we're going to look at a couple of problems that are a little more complex. These numbers don't have the same denominators, just like the other ones had, or they didn't have the same denominators. But these denominators are different because these denominators, I can't do 3 times something to equal 10 or 5 times something to equal 9, so I can create the same denominators. This creates a conflict in which we need to solve these problems using a different method. This method is multiplying by the opposite denominator. When I look at this fraction, 1/3 and 7/10, I'm looking to add them together. And actually, you know, I'm thinking in my mind here, I'm going to switch this over to 6/10 just for simplicity. 1/3 and 6/10. Now, I look at this here, and I can't multiply 3 times something to get 10, but I can multiply by the opposite denominator. Well, I don't know what happened there. I can multiply by the opposite denominator. There we go. Times 10. Times 10. And on this side, the right side, the 6/10, we multiply by the opposite denominator, which is the 3. So times 3 times 3. Draw an arrow down to do my work below. I'll change colors here. Now 1 times 10 is 10. 3 times 10 is 30. Plus 6 times 8, 6 times 3, which is 18. And 10 times 3, which is 30. notice that these denominators are still the same. That's always the goal. And that's why in class I had you draw a line through your notes for the denominators, because I wanted you to see that they are always stay the same. They never change. For the second problem here, I'll give you a second to try it. You can do it on a scratch piece of paper, and then when you're ready, you can press play and you can see the answer. Okay, the answers are in, and the correct answer is 32/45. Notice that I multiplied by the opposite denominator for both the numerator and the denominator on both sides. I did my calculations, my denominators were the same, and I added everything up, and it worked out perfectly. Now, I've used examples of addition. It is exactly the same thing whether you're doing addition or subtraction. The only difference is instead of adding these two numbers together, the 27 and 5 together to equal 32, if this was subtraction, I'd do 27 minus 5 to equal 32. Okay, now it's time for some of the homework questions. Make sure when you send me the email, you number them, like number 1, and then you give me your answer. Number 2, you give me your answer. Number 3, you give me your answer. And number 4, you give me your answer. There will be 4 questions here, and then there will be 4 on the next slide, and then you'll be all set. So you should have 8 problems, plus if you decide to do the extra credit. Okay, here are the first 4 questions. Once you have finished these and written down the answers on the scratch piece of paper and you've done your work, you may then move on to the next questions and press play. Okay, here are the second set of 4 questions. Let me note right here, look at this right here. This is a subtraction problem, number 7. This is a subtraction problem as well, okay? So we have 1/2 plus 2/7, 1/3 plus 1/8, 5/6 minus 1/4, and 2/3 minus 1/20. Once you've solved these problems, you can send me the email. I'm going to write the extra credit question right here. So if you would like to solve this, this would be worth an extra credit point. Just solve it and put it in simplest form. And if you solve it correctly, you will get credit for that. So this is the extra credit, and for some reason my stylus isn't really working here that well. It is 1/4 plus 2/5 plus 8/10 plus 1/3. Okay, you can combine these together, and you'll have to be a little bit creative. We haven't talked about how to do this yet, but once you've done that, you can add that on as an extra credit question at the end. If you have any questions, feel free to call me at 616-212-7413. I'm actually just going to write that number right here. This is my cell number so the whole world can see it. Or you can email me at kweiner@kcsa.org. Okay. I hope this helps and it gets you a step closer to being independent when working with fractions. Thanks so much. Bye-bye.